Hi everyone, Assalamualaikum. In this video, we are going to continue with the final series, which is series 5, a virtual workshop for final exam preparation, Calculus 2 for engineers, MAT235. Hope you enjoy this video. Now we go to another segment, which is sample of final exam paper, right? Right, from this sample of final exam papers, we have 3 printed pages, okay? And then we have 5 major questions. Question 1, 2, 3, 4, and 5, okay? And the total marks equals to 100 marks. And the percentage equals to 60%, okay? And then all these questions you need to answer within 3 hours time, okay? And another 30 minutes you use to scan and upload your answer, right? Next, we look at the sample of solution. Now we continue with question 5A. Question 5A. Okay, this is the given question under Newton's law of cooling, 7 marks. Okay, now we look at the solution. Okay, a bowl of hot porridge at a temperature of 96 degrees Celsius was placed at a room temperature of 23 degrees Celsius. Right, from here we have temperature of 96 degrees Celsius. Okay, so we can write T0 temperature equals to 96 degrees Celsius. Okay, and then from room temperature of 23 degrees Celsius, so we can write Tm equals to 23 degrees Celsius. Right, and then after 30 minutes, the porridge temperature has gone down to 50 degrees Celsius. So we can write T time equals to 30 minutes, temperature equals to 50 degrees Celsius. Alright? And then determine the time taken for the porridge to reach 40 degrees Celsius. So determine the time taken. So T equals to question mark minute. Okay. And then temperature equals to 40 degrees Celsius. Right? Assuming that the temperature of the porridge change obeys Newton's law of cooling, D temperature over D time equals to K times temperature minus Tm. 7 marks. Right? To solve this question, first we start with D temperature over D time equals to K times T minus Tm, right? So from here, using separable equation, so we move T minus Tm to left hand side. So we have 1 over T minus Tm D temperature equals to K, and then we move D time to right hand side. So we have times D time. Okay, K here means constant. Alright. After that, we integrate both sides. So we have integration of 1 over temperature minus temperature of room. D temperature equals to integration of constant D time. Alright. And then after we integrate left hand side, so we get this. Okay, ln and then modulus temperature minus temperature of room equals to, after we integrate constant with respect to T, so we have KT and then plus C, right? Alright, from here, we want to write temperature as a subject. So to write temperature as a subject, first, we move ln to right hand side. So we have exponential function. Okay, so after we move ln to right hand side, so we have left hand side equals to temperature minus temperature of room equals to E to the power of KT plus C. Right? From here, using the properties of indices, so we can split e to the power of kt plus c equals to e to the power of kt times e to the power of c. Okay, e means Euler numbers, okay, which is 2.718 something, okay, which is constant. Constant to the power of constant equals to constant. So we can write t minus tm equals to constant c. Okay, we write e to the power of constant equals to constant c, and then times e to the power of kt. Alright. From here, we replace temperature of room equals to 23 degrees Celsius. So we have temperature minus 23 equals to ce to the power of kt. And we write temperature as a subject, so we have T equals to positive 23 and then plus CE to the power of KT. Alright. Then we can name as equation 1. Alright. From here, we use this info. Okay, when T equals to 0, temperature equals to 96 degrees Celsius, we substitute into equation 1. Okay, so we have 96 equals to 23 plus CE to the power of 0 times K equals to 0. Okay, then we have C equals to 73 because E to the power of 0 means equals to 1. Okay, and then we move 23 to left hand side, so we have 96 minus 23 equals to positive 73. Okay, so C equals to 73. Right? Then we name as equation 2. Right? After that, we use the second info. Okay, when T equals to 3 minutes, temperature equals to 50 degrees Celsius. We substitute into equation 2. Okay, so we have 50 equals to 23 plus 73e to the power of k, and we replace time equals to 3 minutes. Okay, after that, 50 minus 23 equals to 27 equals to 73 e to the power of 3k. Right? Next, we have e to the power of 3k equals to 27 over 73. Okay? When we move e to right hand side, okay, so we have left hand side equals to 30k equals to, we move e to right hand side, so we have ln. Okay, and then 27 over 73. Okay, remember when we move ln to right hand side, it is equals to exponential function. And when we move exponential function to right hand side, we will have ln function. Alright. After that, we can find k. K equals to ln 27 over 73 and then over 30. Okay, and it is equals to negative 0.03315. Alright. After that, we substitute the value of k into equation 2 here. Okay, so we have temperature equals to 23 plus 73 e to the power of, we replace k equals to negative 0.03315 and then t. Okay, after that, we name as equation 3. Right? From the previous slide, we have temperature equals to 23 plus 73 e to the power of negative 0.03315 t, and we name as equation 3. Alright, so now we can find the time taken for the porridge to reach 40 degrees Celsius. Okay, we substitute temperature equals to 40 degrees Celsius into equation 3. Okay, So we have 40 equals to 23 plus 73e to the power of negative 0.03315 t. Right? And then 40 minus 23 equals to 17. Okay? So we have 17 equals to 73e to the power of negative 0.03315 t. After that, we can move 73 to left hand side. So we have 17 divided by 73. Okay? And the other side we have e to the power of negative 0.03315 t. Okay? Now we want to find t. Okay? Time. Okay? So to find time, first we need to move exponential function to right hand side. Okay? When we move exponential function to right hand side, so we can write left hand side equals to negative 0.03315 t equals to, we move exponential function to right hand side, so we have ln and then 17 over 73. Right? So time equals to ln 17 over 73 over negative 0.03315. Okay? And it is equals to 43.96. Okay? Since the time is given in minutes, so we put minutes here. Okay? So this is the final answer. Okay? Next, we continue with question 5b. Right? Question 5b. Okay? This is the given question under topic mixing problem. Okay? So to solve this problem, now we look at one by one. Okay? A tank initially contains 40 gallons. Okay? So initially means time equals to 0. Okay? 40 gallons means volume. Okay? So we can write V naught equals to 40 gallons. Okay? Means volume when time equals to 0. Alright? And then of sugar water having a concentration of 3 pounds of sugar for each gallon of water. Okay? So we can write time equals to 0, Q equals to, we have 3 pounds of sugar for each gallon, means 3 times 40 gallon. Okay? So we have 120 pounds. Okay? And then at time 0, sugar water with a concentration of 4 pounds of sugar per gallon begins pouring into the tank at a rate of 2 gallons per minute. Right? So from here, we can write B equals to 4 pounds per gallon, and then rate of 2 gallons per minute. So we can write R1 equals to 2 gallons per minute. Okay? Simultaneously, a drain is opened at the bottom of the tank so that the volume of the sugar water solution in the tank remains constant. Okay? So from the word remain constant means rate in equals to rate out. So means that R2 is equals to R1, which is equals to 2 gallons per minute. Alright? So from this question, we can write this information. Right? Right, look at this. Okay? We have same rate. Okay? Alright, if we have same rate, means we can use parable equation. Okay? If R1 equals to R2. Or we also can use linear equation to solve this question. Okay? We can use linear equation when R1 equals to R2 and when R1 not equals to R2. Okay? Since linear equation can use for both R1 equals to R2 or R1 not equals to R2. So let's say to solve this question, let's say I use linear equation. Okay. From this formula, dq over dt plus R2 over V naught plus R1 minus R2 times TQ equals to BR1. Okay, this is actually similar to linear equation in the previous video, dy over dx equals to dy over dx plus pxy equals to qx. Alright, but the variable y now we use in terms of q. Okay, and variable x now we use in terms of t, right? So from here, we substitute this information into this formula. Okay, so we have dq over d time equals to, we replace R2 equals to 2, and then over, we replace V naught equals to 40 plus R1 equals to 2 minus R2 equals to 2, and then times T. Okay, and then close bracket, Q equals to B equals to 4, and then R1 equals to 2, right? After that, we have dq over dt plus 2 over 40 plus 0t. Okay, so equals to 40, and then q equals to 8. Okay, then we solve 2 over 40 equals to 0.05. Okay, this is actually similar to linear equation from the previous video. Okay, we have dy over dx plus pxy equals to qx, okay, from linear equation. Okay, but now variable y here we use q, and variable x we use t for time. Alright, and when we solve using linear equation, we need to find integrating factor if. Okay, and if equals to e to the power of integration of px dx. But now our px equals to 0.05 and dx now equals to dt. Okay, when we integrate 0.05 with respect to time, so we have 0.05 t. Okay, so now our if equals to e to the power of 0.05 t. Alright, and after we find if, we can find the solution. Okay, the solution is given by y times if equals to integration of qx times if dx. Okay, but now we use variable y for q. Okay, and then times if. Okay, if equals to e to the power of 0.05t equals to integration of qx. Okay, qx equals to 8. Okay, and then times if equals to e to the power of 0.05t, and then dx equals to dt. Right? Right, how to integrate e to the power of 0.05t dt. Okay, from formula integration of e to the power of ax dx. A means constant. Okay, after we integrate, we have 1 over a, and then e to the power of ax plus c. Okay, now variable x here is t. Okay, so after we integrate e to the power of 0.05t dt, it is equals to 1 over a means 1 over 0.05, and then e to the power of ax means e to the power of 0.05t. Okay, and then plus c, right? And we still have constant 8 in front here. Okay, right, and then we can simplify 8 divided by 0.05 equals to 160. Okay, so we have Q times e to the power of 0.05t equals to 160 e to the power of 0.05t plus c. And after that, we can write Q as a subject. We move e to the power of 0.05t to right hand side. So we need to divide both terms by e to the power of 0.05t. Okay, so we get this. Okay, for Q. Right? After that, we can simplify e to the power of 0.05t over e to the power of 0.05t here. So we have Q equals to 180 plus C. We move e to the power of 0.05t to numerator using the properties of indices. So we have times e to the power of negative 0.05t. Alright? So now we need to find the value of C. Okay? To find the value of C, we need to substitute this information. Okay? But first, we can name this equation with equation 1. Right? Alright, we substitute T equals to 0, Q equals to 180 pounds. Okay? Why 180 pounds? From this information. Okay? 3 pounds of sugar for each gallon of water. Okay, means 3 times each gallon means we have 40 gallon here. Okay, so that's why we have 180 pounds. Okay, we substitute into equation 1 here. So we have 120 equals to 160 plus C, E. We replace T equals to 0. So we have to the power of 0 here. Okay, after we multiply this. Okay. E to the power of 0 equals to 1. So we have C. Okay, 1 times C equals to C equals to 120 minus 160 equals to negative 40. Okay. After that, we substitute the value of C into equation 1. Okay, so we have number 1, an expression of the amount of sugar in the tank at any time t is given by Q equals to 160 minus 40, okay, because we replace C equals to negative 40, and then E to the power of negative 0.05t. Okay. From the previous slide, we have Q equals to 160 minus 40 e to the power of negative 0.05t, and we can name as equation 2, right? So now we can answer question Roman 2. Okay, the amount of sugar in the tank after 15 minutes. Okay, we substitute T equals to 15 minutes and we can find the value of Q. Okay, we substitute into this equation. Okay, so we have Q equals to 160 minus 40 and then e to the power of negative 0.05 and then we replace t equals to 15. Okay, and after we solve using calculator, so we have Q equals to 141.1 pounds. Okay, this is the amount of sugar in the tank after 15 minutes. Alright. Next, question number Roman 3. Okay, how long will it take for the sugar content in the tank reach 150 pounds? Okay, so how long means we want to find T when Q equals to 150 pounds. Okay, we substitute into this equation, okay, into equation 2. So after we substitute, we have Q equals to 150 equals to 160 minus 40 and then e to the power of negative 0.05t. right? Right, after that, we move negative 40e to the power of negative 0.05t to left hand side. So we have positive 40e to the power of negative 0.05t equals to 160 and then minus 150, right? After that, we have 40e to the power of negative 0.05t equals to 10. And then e to the power of negative 0.05t equals to 10 divided by 40 equals to 0.25. And then now we want to find t, okay? So we move e to right hand side. So we have left hand side equals to negative 0.05t equals to, after we move e to right hand side, so we have ln 0.25, right? And we have t equals to ln 0.25 and then over negative 0.05, okay? And it is equals to 27.73, and then we put unit minutes here, okay? Because the unit given in this question is minutes, right? So the time taken for the sugar content in the tank reached 150 pounds equals to 27.73 minutes, right? We now come to the last question, question 5C. Question 5C. Solve the second order differential equation y double prime plus 4y prime plus 4y equals to 5 sin x minus 10 cos x, 8 marks. Okay. Right, to solve this question, step 1, we need to find yg. Okay, means we need to solve homogeneous equation for second order ODE. Right. Homogeneous equation means we write y double prime plus 4y prime plus 4y equals to 0. Okay, we equate to 0. Okay, when we solve homogeneous equation. Okay, after that, we replace y double prime equals to m squared, y single prime equals to m, and y equals to m to the power of 0, which is equals to 1. Okay, 1 times 4 equals to 4. So we have m squared plus 4m plus 4 equals to 0. This is characteristic equation, right? And this is also quadratic equation. Okay, so we can factorize it. Okay, after we factorize, we get this. M plus 2 times m plus 2 equals to 0. So we have m equals to negative 2, which is repeated roots. Alright? So our yg for repeated roots equals to c1e to the power of mx plus c2x e to the power of mx. Okay, then we replace m equals to negative 2. So we have yg equals to c1e to the power of negative 2x plus c2x e to the power of negative 2x, right? After we find yg, we continue with step 2. Okay, find yp. To find yp, we need to solve non-homogeneous equation. Non-homogeneous equation means right hand side not equals to 0. In this case, right hand side equals to 5 sin x minus 10 cos x. Okay, and from here we can name as equation 1. Okay, from the given equation. Alright, then we can find yp. Yp means trial solution based on the function on the right hand side. Okay, so from here we have term containing sin x and cos x. So our trial solution YP should be equals to A sin X plus B cos X, right? From here, we need to differentiate YP. So we have YP prime equals to, we differentiate A sin X, we have positive A cos X. And then we differentiate B cos X, we have negative B sin X. Alright? We need to differentiate 2 times. Okay, so after that, we find YP double prime equals to, we differentiate A cos X, we have negative A sin X, and then minus B, we differentiate sin X equals to cos X. So we have minus B cos X, right? After we find YP, YP prime, and YP double prime, we need to substitute into equation 1 to find the values of A and B so that we can find YP. Okay? So after we substitute YP, YP prime, and YP double prime into equation 1, so we have YP double prime. We replace YP double prime into Y double prime. And then plus 4, we replace YP single prime into YP single prime. And then plus 4, we replace YP into Y. Okay, and then equals to 5 sin X minus 10 cos X. Alright? After that, we replace YP double prime equals to negative A sin X minus B cos X. And then plus 4, we replace YP single prime equals to A cos X minus B sin X. And then plus 4, we replace YP equals to A sin X plus B cos X. Okay? And it is equals to 5 sin X minus 10 cos X. Right? From the previous slide, under step 1, we have YG equals to C1e to the power of negative 2x plus C2x e to the power of negative 2x. And then after we continue with step 2, we get this. Right? Now, we want to find YP. Okay? Before we find YP, we need to find the values of A and B. Okay? So from here, we rearrange and we expand this. Okay? So we have negative A sin X minus B cos X, and then plus 4 times negative B sin X. So we have minus 4B sin X, and then plus 4 times A cos X. So we have plus 4A cos X, and then plus 4A sin X, and then after we expand this, we have plus 4B cos X. We arrange based on the same coefficient, okay, so that it is easy to simplify. And all of this equals to 5 sin X minus 10 cos X, right? After that, we have minus A plus 4A, and then sin X. So we have 3A, and then minus 4B in bracket sin X. Okay? We simplify this. Okay? And then we simplify term containing cos X. So we have 4B minus B equals to positive 3B, and then we have 4A here. So we have 4A plus 3B in bracket cos X equals to 5 sin X minus 10 cos X. Alright? After that, by comparing the coefficient of sin X, Okay, because now we want to find the values of A and B. Okay, so when we compare the coefficient of sin x and cos x, okay, after we compare the coefficient of sin x, we can write 3a minus 4b equals to 5, right? And then we can write 3a and then minus 5 equals to 4b, and b equals to, we move 4 to left hand side here, so we have 3a minus 5 over 4. Okay, and then we can name as equation 2. Okay, because we already have equation 1 in the previous slide, right? And after we compare the coefficient of cos x, okay, for both sides, so we can write 4a plus 3b equals to negative 10. Alright? Then we can name it as equation 3. Okay? From here, we need to solve simultaneous equation to find the values of a and b. Right? So after that, we substitute 2 into 3 here. Okay? So from equation 3, we have 4a plus 3b. So we replace b equals to 3a minus 5 over 4. And then equals to negative 10. Right? From the previous slide, under step 2, we get this. Right? So from here, to eliminate denominator 4 here, we multiplying each term by 4. Okay, so we have 4 times 4a plus 4 times this term, okay, equals to negative 10 times 4. Okay, so from here we can simplify 4 here and 4 in denominator here. So after we simplify this, so we have 16a plus 3 times 3a minus 5, no more, over 4 and times 4 here, okay? And then equals to negative 40, okay? Next, we have 16a plus, we expand this, so we have 9a minus 15 equals to negative 40. And then 25a equals to negative 40 plus 15, so we have negative 25. So our a equals to negative 1, right? Then we substitute a equals to negative 1 into equation 2. Yeah? So we have b equals to 3 times a. We replace a equals to negative 1. And then minus 5 over 4. Then it is equals to negative 8 over 4. And after we simplify, we have b equals to negative 2. Right? From the previous slide, under step 2, we get a equals to negative 1 and b equals to negative 2. Right? After that, we substitute the values of a and b into yp. Okay? We recall back, yp equals to a sin x plus b cos x. Okay? So after we substitute the values of a and b into yp here, so we get yp equals to negative sin x and then minus 2 cos x. Okay, this is our yp. Alright. So at this point, we done step 2. Alright. Next, we continue with step 3. Okay. The solution is given by y equals to yg plus yp. Okay, so the solution is y equals to, we replace yg equals to c1e to the power of negative 2x plus c2x e to the power of negative 2x, and then plus yp. Okay, this is our yp. So we have minus sin x minus 2 cos x. Right? This is the solution for this second order differential equation. Right? Got it? Yeay! Kita dah berjaya habis discuss satu set sampel soalan final ya, Madam? Ya, anak-anak. Selesailah sudah bengkel persediaan menghadapi final exam MAT235 Calculus 2 for Engineers. Harap anda dapat manfaatkan sebaik-baiknya ya. Good luck for your coming final. Semoga digunakan ketenangan, kefahaman dan fokus ketika menjawab soalan. You can subscribe, like and share to support this channel. Thank you for watching. All the best.